In this video, we'll use substitution method for solving, meaning we're finding values for x and y to make each of these equations true. Now, why are these, for example, separated? Let's find out. First example, we're trying to isolate one of the variables. So in this case, we'll isolate the y, which results in 4 minus 3x. We'll use that value and plug in. Distribute. And collect like terms. Subtract 12 both sides. Divide by -7. So we found x is equal to 0. Use x equals to 0 to find out what y is. Now let's check if our solution is true. We'll plug in the values. 3 times 0 plus 4, does that equal 4? And 4 does equal 4. How about the next one? Checking to see if the left side equals the right side, and yes, it does. So we have a solution. Let's move on. Let's isolate one of the variables. Adding 2y to both sides becomes, perform the substitution, 9x plus 4 times 3/2 x is equal to 5. So we have 9x, common factor of 2, plus 6x is equal to 5. 15x is equal to 5. Divide by 15, and careful here, we actually have 1/3, reducing to get 1/3. Now we'll use x is equal to 1/3 in the first equation. So y is equal to 1/2. We have an x value of 1/3 and a y value of 1/2, but we're not sure. Let's check. Plugging in our values, we have 3 times 1/3, subtract 2 times 1/2. Does that equal 0? In fact, we have 1 subtract 1, and that does equal 0. Second equation, 9 bracket 1/3 plus 4 bracket 1/2. Does that equal 5? Well, we have common factor of 3, so 3 plus common factor of 2. Does that equal 5? And 5 does equal 5. First step, isolate one of the variables. This time we'll choose to isolate the x. Now we can use that value to find out the y. And we'll distribute and get 8 minus 4y plus 4y is equal to 8. Collecting our like terms, now we have a problem. So what does this actually tell you? If you look at both of the original equations, the second equation here is actually a multiple of the first, meaning if we times the first by 2, we actually get the same equation. These two equations create the same line. They are collinear, meaning there are infinitely many solutions for this particular system. We'll isolate the y. So we have 3x minus 6 is equal to y. 6x minus 2 times 3x minus 6 is equal to 2. We have 6x minus 6x plus 12 is equal to 2. And collecting our like terms creates 0x is equal to, subtract 12 both sides, negative 10. Divide by 0, impossible. So why did that happen? If we isolate the y in the second equation, now the first equation gives us a slope value of 3 and a y-intercept of negative 6. The second equation gives us a slope of 3 and a y-intercept of negative 1. We actually have parallel lines with different y-intercepts. And that is why these two equations cannot be solved, because the lines never cross.